So welcome to the day 2 session of understanding Unix commands. The first one that we will discuss today is the ls commands. The ls command is used to list the contents of a directory, which is quite similar to the dir command in case of Windows. So we are talking about a command line environment where if you go to a certain directory and if you want to list out the contents of that directory as to which files subdirectories are present into it, in such cases we use ls command to list those contents. In a classic GUI environment, the equivalent action of it is to open a Windows Explorer and then go to a particular folder, and the Windows Explorer would list out the contents of that particular folder. So in a command environment, the equivalent action is to type the ls command. Now until I mention explicitly, all Unix commands are in lowercase. Unix is case sensitive unlike Windows. So if you type ls all in lowercase as against ls in capital case, it would have two different meanings. And then there is no uppercase ls command available in Unix, which means if I type an uppercase ls, it would definitely error me out. So my command interpreter, which in this case is a bash shell, has interpreted capital ls to be one of the valid commands, but when it couldn't find, then it has thrown me an error saying command not found. So that's where I said until and unless explicitly stated, all Unix commands are to be treated as lowercase, and Unix is case sensitive. In its most generic format, one would type ls syntactically in this way by saying ls, those square brackets meaning these options whatever I mentioned within square brackets are optional. So you can go ahead with ls command even without mentioning the options, and followed by directory list. Again, directory list has been mentioned in square brackets, which means it's optional. So in its most simplest form, ls could be typed as a standalone command without options, without the directory list. But a full-blown ls command in a generic syntactical way could be written as ls followed by options followed by directory list. When the directory list, that is this option, is not supplied, the ls command would list the contents of the current directory. So when I do not mention the name of the directory explicitly, then the ls command, or for that matter most of the other Unix commands, would assume that you are about to type this command against the current working directory or present working directory. That's where I said when the directory list is not supplied, the ls command would list the contents of the current directory. The current directory in Unix can be indicated using a shortcut notation called as dot. So if I want to refer to my current directory, I could say ls dot. Even if I don't mention for the ls command, then by default it assumes it to be a current directory. So if I want to see what's there in my current directory, as of now there is nothing. I don't see any files, any subdirectories, at least the ones that are visible in general are not. There may be hidden files and folders there, but simple ls command without any option at least does not list me any of those contents in my current directory, which means in my current directory, apart from hidden files, there aren't any other files or subdirectories which can be listed with the ls command. So the current directory in Unix can be indicated using a shortcut notation called as a dot, and the parent directory in Unix can be indicated using a consecutive dots without a space in between. So if I want to refer to my current directory, I would have said show me the contents of my current directory, or even a shorter way to say ls, because by default it assumes it to be a current directory. If I was to list the contents of my parent directory, first let's know where are we. So I'm logged in as user Dick, and I'm connected to the machine named slodum-dr, and on that machine I am in the folder. Under root there is a folder named home, and under home there is a subfolder named dict, which is also my home directory, which also is my present working directory. So if I say ls dot or simply ls, that means show me the contents of my current working directory, and my current working directory is /home/dict. But instead if I say double dot, that means show me the contents of my parent working directory. Parent in my case is home. So it shows me what's there in the home directory. So in home directory there are multiple other files or subdirectories. In this case the blue color indicates, remember this is only for Linux that you get to see colors. Otherwise it's all a black and white environment. So you won't come to know from these blue colored ones. I can see that these are all subdirectories, because directories in Linux in a colored format are indicated with a blue color. So from the color itself I can identify that these are not the files but directories. But the point is, double dot helps you to obtain a list of files from the parent working directory. Now whichever command you use dot will mean the current working directory, your present working directory. Whichever command you use double dot would refer to the parent of the current working directory. So it's always the parent of my present working directory. If my present working directory is /home/dict, then the parent of it automatically becomes the home directory. So in short, here I meant show me the contents of my parent directory, which translates to /home, and it has listed me the contents of my home directory. The blue color, as I said, indicates that it's a directory, it's a folder. But in other Unixes where the ncurses libraries are not available, that is how it is normally installed, you won't see the colors, you won't see the modified shell displaying you the color. So everything would be black and white, and that's the time when it becomes difficult for you to identify, is it a file or is it a directory, because there is no color convention in case of a classic black and white command terminal. So the parent directory in Unix can be indicated using a double dot. So in short, if I type ls command, automatically, since I didn't mention here any directory list, it will assume that I want to run it against my present working directory, whichever directory I am into. It will list me the contents of that particular directory. In other way, I can be slightly more explicit while saying ls space dot, where dot indicates my current working directory as a shortcut notation. So these two commands are equivalent. When no options, by options I mean this is what you mention using the option, which itself is enclosed in square brackets, which means options are optional. I may or may not type them. So when no options are specified, the output is displayed in multi-columnar format like this. So see here, I got the output in multiple columns. But this output does not tells me about what type of files are they. So are they the directories, are they the files, there are multiple other type of files in Unix, such as a symbolic link, a block special device, a character special device, a pipe, a socket. I don't get to know simply by ls command without options that what type of a file I am dealing with. So you can use below options in ls command for more meaningful output. So you can type ls-l. -l displays the contents of the current directory in a long list format. Now what I mean by long list format, let's check this out. I said ls hyphen l, where hyphen l is the option, and I wanted to obtain it about my parent directory. Now see how different is the output now. Now earlier it has shown you the output which was multi-columnar. Now this time it's multi-columnar, but additional file attributes are also displayed. All these columns are additional file attributes. Earlier it only showed me the names of the files or contents within my parent directory, which includes this particular list. Now I get to see additional columns in my ls output. Now it's very important for all of us to understand what is the meaning of each of those columns. The first column, so let's understand what does that output shows us in that ls-l output. I am trying to analyze what is the meaning of each of these columns listed in my ls-l output. Let's focus only on the first column and understand the meaning. I am talking about only the first column. The first column is a 10 character column. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 10 characters. The first column is a 10 character column. The first character of the first column shows the file type. So when I am looking at the first character of the first column, it shows me the file type. For all the files that I see in my current output, all of them are shown as D. D stands for a directory. Let's see what one could expect in the first character position of the first column, which is of 10 characters in width. D stands for a directory. If there would have been a hyphen in place, a hyphen indicates a regular file. A P indicates a pipe. Pipe is a data structure. S indicates a socket. L indicates a symbolic link. C indicates a character special device file. B indicates a block special device file. But as of now, obviously I do not have files of any other type here. So in this case, I only see all of them are directories. But see here, directory 1 and directory 2 are reportedly shown as directory type of files, where file1 and file2.txt are reportedly shown as a hyphen. A hyphen stands for a regular file. You see, I just created another different type of a file which is of the type P, a pipe. I just created another type of a file which is reportedly shown as L. L stands for a symbolic link. Well, so on and so forth. You could have files of these nature. So directory, regular file, pipe, socket, symbolic link, character special device file or block special device file. However, the most common ones that you would be working against would be a directory and a regular file. Apart from this, you might work with a symbolic link. Let's not worry what are those file types, but understand what those notations mean. The next three characters, which is the first character is excluded now. The next three characters, like this one, RW hyphen in my case. The next three characters of the first column shows the permissions for the owner of the file. This indicates what permissions the file1.txt has for the owner of the file. The owner of the file is Dick. So Dick has read permission on the file, write permission on the file, and no execute. Typically the permissions are mentioned as read, write and execute. If there is a read permission, you would see R. If there is a write permission, you would see W. If there is a execute permission, you would have seen a small x. In the absence of a permission, instead of using R, you would have seen hyphen, which means no read. Instead of W, you would have seen a hyphen, which means no write. If you would have seen instead of X hyphen, which means no execute. So the positions and the order is fixed. So second character, third character, fourth character respectively are for read, write and execute permissions on that file for the owner of the file. Owner of the file itself is indicated by the third column. So owner for my file is Dick, which means Dick indeed has read permission, write permission, but Dick does not have execute permission on that file. The next three characters of the first column shows permissions for the owner of the file. The permissions are mentioned as read, small r, write, small w, and execute, small x. So that's how you need to interpret the next three characters of the first column. Now I am talking about the subsequent three characters of the first column, which is that I want to highlight about this. The next three characters of the first column shows permissions for the group members. The permissions are again mentioned as R for read, W for W for write and X for execute, which means whosoever is the group member. Which group I am talking about? User is Dick, he is a member of Dick group. But consider another case. Here who is the owner? User1. To which group user1 belongs to? Unix lab. So the next column of three character indicates, which is this portion, what permissions member of Unix lab group would have on a given file. So if I see in this case, members of Unix lab group would have read, no write, but execute permission. In this particular case, members of Unix lab group on the file small.txt would have read but no write and no execute. In this particular case, they would have read and execute but no write permission. So the characters from character position 5, 6 and 7 indicates read, write, execute permissions for the group members. And then I am talking about the last three characters, respectively character position 8, 9 and 10. The last three characters of the first column shows the permissions for others, and by others I mean not the owner and not the group member. So anybody other than owner and group member automatically is treated by Unix as others. So what would others have on this file permission wise? So if I say pop.txt, others would have read, no write, but execute. If I see this permission character position 8, 9 and 10 for a file name var.txt, text, others would have only read permission. They cannot write to a file. They cannot execute this file. Anyone who is not user 30 or not a member of Unix lab is called as others. In my case, I was user 1. So anybody who is not user 1, anybody who is not a member of group Unix lab is automatically treated as others. And what permission others would have is indicated by the character position 8, 9 and 10 from the first column of ls-l output. The second column shows link count. By default, a directory would have a link count as 2. A file by default would have a link count as 1. Let's see. So here I am back to dict. I list out the files in a long list format from my current working directory, since I didn't mention the directory list path. So it automatically defaults to current working directory. So whenever I create a directory, the link count column will automatically show a value as 2. And for files, it will automatically show me a value as 1. If a file has multiple aliases, by aliases I mean alternate names, then the link count would show how many such aliases are there. For example, none of my file here has alternate name, alias, token now. So none of my file has an alias. That's why all the files are reportedly showing me the link count column value as 1. Let me create an alias for file 2. So for file 2, I created an alternate named file called as alias file 2. See for this now, what type of a file is this one? Regular file. What is the link count column showing? 2. What is the file type for this file? Regular file. What is the link count column showing? 2. Now whenever you see for a regular file, link count link count columns value higher than 1, it means the file has alternate names, aliases. So see what I mean by an alias. Let's not worry about the command part. Commands we'll discuss anytime in future about ln command. So I am writing something into this file. This is file 2.txt. Now if I see what's there in the alias, see what is there, which automatically means file 2.txt has an alternate name alias underscore file 2.txt, because ultimately they are pointing to the same file. So in Unix, which is quite new for us, a file can have multiple different names. Remember, it's not a copied file. A copied file would have shown me contents only at the time of copy. If my original file gets modified after that, my copy would not have been affected. But this is not a copy. It's simply an alternate name given to the same file. Now I want to modify alias file2.txt, saying this line was added into this thing. And now if I say cat file2, see here, which means file2.txt and alias underscore file2.txt are two different names for the same file. And that is why in the link count column, you should see value 2. If I create one more alias for the same file, you would have seen the link count value going by 1, going up by 1. So for the same file, file2.txt, I am creating another alias file2.txt. Now if I see now the link count value is showing as 3, which means apart from the file's original name, there are two additional aliases created for the same file. Now if I see the contents of this file, the contents of this file, the contents of this file, all of them are same, which means I'm not talking about three different files. I'm talking about the same files with multiple names. So the second column shows the link count by default a directory would have a link count as 2, a file would have a link count as 1. If a file has multiple aliases, which means alternate names, then the link count would show how many such aliases are there. For a directory, the link count column shows how many subdirectories are created under your directory. Now let's see. So for a directory, I see the link count column is showing as 2. Now question is, these are not the aliases, then why it is showing as 2? For directory, the convention is somewhat different. I said, show me what's there in the directory. You see there are 2 subdirectories in my directory. Dot to indicate current working directory. Double dot to indicate parent of the current working directory. So these 2 subdirectories are automatically created whenever you create one directory. That's why the link count for any directory by default would show you value as 2. Now if I go into directory 1 and I create a subdirectory inside it. So how many total directories are there now inside my directory 1? 3. Dot to indicate myself, double dot to indicate my parent, and apart from that there is a subdirectory called as subdirectory 1. If I come one level up and say ls-l, see what is the link count column showing now? 3. So for a directory, a link count column shows how many direct subdirectories exist within that directory. So how many directories are there in it? 3. That's why it's showing. 2 of them are always hidden. Dot and double dot. Dot is to refer to that directory itself, and double dot to indicate a parent of that particular directory. Apart from that, I just created one subdirectory inside it. That's why the link count value has gone up by 1. If I go to directory this thing, and then if I delete this one and I come back and I say ls-l, the count has again gone down by 1, which means now there are only 2 subdirectories inside the directory 1, and those are always hidden. Those hidden directories are dot and double dot. Dot to indicate directory 1 itself, double dot to indicate parent of directory 1, and parent of directory 1 is nothing but /home/dic. The third column shows the owner of the file or directory. So this is my third column. So who is the owner of this file or a directory? Dic. The fourth column shows the group name to which the owner belongs to. Or in other words, it shows the group ownership of the file. So by default, it will show you the name of the group to which your owner belongs to. So let me switch in momentarily as user1, and let me create a directory called as testdir. If I see testdir, it says who is the owner? User1. This is who I am currently. I am user1, member of the group Unix Lab. So what does it indicate here? The group ownership of that file is to Unix Lab group. That means anybody who is a member of Unix Lab would be able to do these operations with the file. That means Unix Lab members can read and can execute on a directory. They do not have a write permission on that directory though. The fifth column shows the size of file or directory in bytes. So I come out back to my account. Who am I? I am Dic. So I am saying what size is that of that file. Remember 59, 59, 59. Why? Because I am talking about the same file. They are just multiple aliases. So what is the size of this file? 59 bytes. And for a directory by default, it will show you an empty directory shows a size of 4 KB. The fifth column shows the size of file or directory in bytes. An empty directory often consumes 4 KB disk space. So if I create a directory, the directory structure itself consumes, even when it is empty, it consumes 4 KB of disk space. The sixth column shows the last modification timestamp for a given file or directory. Now don't confuse. This whole thing is column number 6. So don't treat this as 6, 7, 8. This whole thing is column number 6. This shows me when was the file last modified. I check what is the date now. It's 8:44 AM on January 23rd. When was my file last modified? My file alias file2.txt was modified at 8:37. I edit it and I am saying modified. See here, what's the time now? 8:45 for this and this, because ultimately I am talking about the same file. They are just aliases for the same file, which indicates when was my file last modified at 8:45. So last modification timestamp is what is another attribute that you get to see as the sixth column in ls-l output. And seventh column, self-explanatory, name of the file or the directory. The seventh column shows the name of the file or directory. You would only see one odd man out, and that is this, which is showing as a pointer to something else. Let's not worry as of now. What is that? It's called as a symbolic link. Here it means file3.txt is actually a pointer to file1.txt. Let's not worry about it. Once we get on to the ln command, that time I will explain what is the difference between a hard link and a soft link. In which case to use a hard link and in which case to use a soft link. So I just talked about -L option to obtain a long list in the for the ls command. By long list it means display me additional attributes of a file. So that ls-l option shows you long list, which means additional attributes of a file. Why I did this thing? Because in the absence of it, it's very difficult for you to find out what type of a file I am dealing with. So to list out additional attributes, use -L option of ls command. -A option shows hidden files as well. So I am creating a hidden file. See here. It's very simple to create a hidden file in Unix. Any file or directory name that starts with a dot is treated as a hidden file. See here. So I created one file named .secret_file.txt. Name starts with a dot. I created another hidden directory called as secret_directory. Name starts with a dot. So whenever the file or a directory name starts with a dot, it is treated as a hidden file. I say ls-l, you don't get to see them. So none of my files are listed here. But if I say ls-l, L is to display a long list, A to display hidden files as well. Now you see .secret_file.txt, .secret_directory as well. There are multiple other hidden files also, such as .bash_logout, .bash_profile, .bash_rc, .emacs, .kd, .mozilla, and so on and so forth. They are not the ones that I created. They are automatically created by your system. But the point here is, whenever you create a file or a directory with a name with the name beginning with a dot, it will be treated as a hidden file and won't be listed until you use -A option. So understand what I did here, just -L for a long list and -A to include in my output hidden files as well. If I don't use -L, I get multi-columnar output. Hyphen A will also show me hidden files. So the default behavior is to display the output of ls command in multiple columns. And since I included A, it also has listed me hidden file. But now God knows what type of a file I am working with. Is it a file, a directory, a symbolic link, a pipe, a block special device, a character special device, or a socket, or a pipe? I don't know, because I don't get to see the additional attributes. So hyphen A shows the hidden files. When a file or a directory name starts with a dot at the beginning, Unix treats it as a hidden file. And by default, hidden files are not listed in the ls output. Hyphen small r simply reverses the outputs or order of the output. It simply reverses the order. Now understand this. If I say ls hyphen l, let's understand in what order those files are listed. What could be the order? If I understand this carefully, you will observe that the file names are listed in the alphabetical order. Well, I didn't like this order. Then I can say ls hyphen lr. Now it has simply reversed the order of the output. So whatever was earlier listed on the top is now listed at the bottom. Whatever was listed at the bottom is now listed on the top. It simply reverses the order in which the output appears. This is for you to sort when you are dealing with a directory which has several files, and by default they are listed in the order of A to Z. So you may want to reverse the output. Hyphen T sorts the ls output according to the last modified timestamp. Now last modified timestamp is column number 6. You see, as of now there is no specific order. They are at random, because I told you there is only one order by default in a ls hyphen l output, that is alphabetical order. So when I display those files in an alphabetical order, you have noticed there is no order for the timestamp. If you want to sort it on the timestamp basis, you could say ls hyphen l for a long list and t for a time based sort. Now see here, recently modified files are shown at the top and oldest modified files are shown at the bottom. Well, I didn't like this concept. I wanted oldest file should be displayed on the top and recent most file should be displayed at the bottom. Then you know L for long listing, T for time based sorting, and R to reverse the output. Now see here. So L for long listing, T for a time based sort, and time based sort would have displayed me recently modified files on the top, oldest modified files at the bottom, but I simply want to reverse this, which means oldest modified file should be shown on the top and recently modified file should be shown at the bottom. So R simply reverses the output. Now of what? Then it must follow that proper tagging. So if I put a R immediately after T, so whatever is the output of sorting it on the timestamp basis, it will reverse it. If I put it against LR, so long listing displays it in the alphabetical order, it will do it in a reverse alphabetical order if I put an R against an L. This would simply display the recently modified files on the top and older files would be shown at the bottom. If you don't like this, put an R against it, it will simply reverse it. Hyphen small d shows the directory attributes. Now let's understand what I mean by a directory attribute. If I say ls hyphen l, see what it displays. It displays me list of contents within my current working directory. Well, I don't want to see it from the current working directory. I wanted to see directory attribute for directory 1 only. So I typed directory 1. But the problem is now it shows me the contents from directory 1. But the objective is I don't want to see the contents of directory 1. I want to see only this line. That is, from my current working directory, what are the directory attributes? In such cases, you include D. Understand the difference. D stands for show me the directory attributes. So the directory attributes means it will not list everything. It will only filter out a specific directory. And by specific directory, I do not mean the contents in that directory. If I exclude that D, very well you found out that it's not displaying you the directory attribute for directory 1, but it is listing you the contents of directory 1. I don't want to see the contents of directory 1. Instead, I want to see in a filtered manner the attribute for the directory itself. That's why you must include the attribute or the option -D. -D is to display directory attribute for the directory which you have mentioned. People say, what if I don't mention this? Then by default, what is treated? Current working directory. It shows me the current working directory's attributes. So -D shows the directory attributes, such as if I say ls-ld followed by dir1 shows the directory attributes and not the contents of the directory itself. If you don't include D, it will show what lies beneath directory 1. Well, I don't want to see, I don't intend to see what lies beneath directory 1. I wanted to see what are the attributes itself for directory 1. -R recursively shows the contents of all the subdirectories below a given tree. See here. I go to directory 1 and I create dir1a, dir1b, dir1c. Then I come out. I go to directory 2 and I am creating dir2a, dir2b. Then I am coming out. Now see what happens. Understand where I am first. I am in my home directory. If I say ls-l, it only shows me the contents of my given directory. If I have not given the directory, default it assumes as a current working directory. So in my current working directory, I have these many files and subdirectories. But what if I want to recursively go and drill down into each of those directories and see what lies beneath? Then I must use R. See here now. R is for recursive listing. Well, I didn't mention any path, which means it is current working directory. Now see the difference. It says in your current directory there are these many contents. Then in your current directory there is a subdirectory called as dir1 and it has these many contents. And in your directory, current directory, there is a folder called as dir1 and there is a subfolder called as dir1a. It has this thing, nothing, total 0. In your current directory, there is a subdirectory called as dir1 and in dir1 there is dir1b. It has nothing. Then in your current directory, there is directory 1 and inside it there is a directory 1c. There is nothing there. In your current directory, there is directory 2 and within directory 2 you have dir2a, 2b. And within your current directory, within directory 2 there is dir2a but there is nothing there. In your current directory there is dir2, inside dir2 there is dir2b but there is nothing there inside it. So -R is to recursively list out the contents of anything that lies below a certain directory tree. In my case, since I didn't mention the path, it has filtered me everything starting from my current directory and below it. If I would want to see only for directory 1, the output would have been something like this. So it has listed me what lies beneath directory 1 recursively. -I shows you the inode number of a file. Each file in Unix is given by the file system a unique inode number. However, there is an exception. Let's see. Simply speaking, when I say ls-l, it shows me a 7 columnar output. If I say ls-li, it shows me an extra column. This is nothing but inode number of that file. Remember, during the file system discussion in the classroom, I said how the files are tracked. Whenever you format a given disk in Unix, it will receive a file system. By file system, it creates an empty register. In Windows, that register is called as a file allocation table. In Unix, it's called as an inode table. That inode table talks about file attributes as and when you store files on that given disk or the disk partition once it is ready to use. One such attribute was inode number, the file ID or the inode number. Now if you see, each file ID is unique except for this 200720. Now why it is showing the same ID for more than one files? Because it's the same file. I just created multiple aliases for the same file. This proves that file is one, but there are multiple names for that particular file. So these are nothing but the aliases for that file. But other than this, if you see any other files inode number, it's different. So only for hard links, the inode numbers would be same. For any other file other than a hard link, all the files will bear a unique inode number. An inode number is unique within a given file system. More on that at a later time. What is a file system? Can an inode number be duplicated on the same system? Answer is yes, provided I am talking about two files belonging to separate file systems. So I said inode number is unique within a given file system, and inode number itself can repeat on a given system across different file systems. So if I am talking about two different file systems, those two different file systems may have the same inode number, although they are on the same machine. But within a given file system, within a given formatted disk or a disk partition, inode number will not be duplicate. There is only one file which may show you a duplicate inode number, and that is a hard link. Well, is that all about ls command? Answer is no. These are some of the most popular ls options that you use. Apart from that, there are several ls options. So whenever going forward, if you are stuck with a given Unix command, the best thing to do is to find out or read the help manual of that command. And to obtain a help manual of any command, simply type man. Man stands for an abbreviated manual, followed by the command ls. It will display you the commands manual. So I said ls list directory contents. In its most generic format, ls is written as ls followed by option followed by directory list, and the options are a, b, whatnot. See, several options are there, but the ones which we use most frequently in our routine life, I have discussed about only those options. Now understand, this is -l and this is 1. This is 1. Understand the typographical differences. The first one is L, the next one is 1 as a digit. There is one more option called as -1. See what it displays. -1 means show me all the files in a single column. If I don't type, I get multi-columnar. If I type ls-l, I get additional attributes. But if I say ls-1, all the files in my current working directory are listed only in the one column output. So likewise, there are multiple other options of ls which we didn't discuss. We are only discussing the ones that are most frequently used in routine life. Those which are very generic across all the Unix flavors. Probably ls-1 will not be available on all the Unix platforms. It may be only an enhancement done in Linux. But if I go to Solaris, probably I may not have any option called as -1. So our job is to master all the options that we use in a routine life, and then apart from this, to go through the manual to improve upon your efficiency. So just to understand what are the other options possible, to go through the man pages. So I told you an easiest way to obtain and help is to type man further followed by the command. I typed man pwd, it shows me the help of pwd command. People say how to use man, then type man. Tell me help about help. Then it says man formats and displays the online manual and whatnot. Clear? Remember, this man command is a unisex command. So the diversity candidate should not expect a woman command for them. The computer has only one command, that is man, and man is an abbreviation not to indicate a gender but an abbreviation for a manual. Clear? On a lighter vein. The next one is cd for change directory. You can move between or navigate from one directory to another using the cd command. In its most generic format, cd is optionally followed by where you want to go to. First you must know where you want to go to. The directory itself you must know. And when you do not mention, the whole thing itself has been indicated into a square bracket, which means that is also not required. See what it means by that's not required. So I go to directory 1, and if I print my present working directory, this is where I am. I am in /home/dict/directory1. If I want to navigate elsewhere, I would have typed cd followed by whatever I should have mentioned here, the path wherever I want to go. But I told you this whole thing itself is included in square bracket, meaning it's itself optional. So I can simply type a command cd without any argument. See what happens now. Understand where I am. I said cd, no arguments, enter. See where I am now. I am in my home directory. That's what I said. You need not mention anything. cd followed by an enter will take you back to your home directory. So normally what happens? You keep on navigating throughout your day. You are working, you are moving from one directory to another to another, and it's at the end, it's so complex, I don't know where I am. You can always type pwd to find out where you are, but the best way to get back to your starting point is to say cd followed by an enter. This will take you back to your home directory. I call it as laut ke buddhu ghar ko aaye. cd enter takes you back to your home directory. So it will take you back to your home directory. If not, mention the path. If you want to navigate elsewhere, I am mentioning the path now. Understand this. cd directory 1 dir1a. See where I am now. Now understand the way I mentioned it. I said cd directory 1, directory 1A, did I mention any path here? When no path is mentioned, then what is assumed? Current working directory, which means it's as good as saying this thing. If I don't mention, it automatically assumes what is the path? Current working directory. I could have written the current working directory like this as, yeah, so I would have said, I simply said then cd directory 1 slash dir1a. Well, I didn't mention where is directory 1. The path to directory 1 itself was not mentioned. In which case, it would assume it to be a current working directory contains directory 1 and directory 1 in turn contains dir1a, take me there. Another way to write it could have been dot slash. Dot indicates my current working directory. So I said in my current working directory, there is directory 1. Inside directory 1, there is dir1a, take me there. I am coming back to my home directory. I am going there one more time. I said pwd. I am coming back to my home directory one more time. I said pwd. I am saying this time followed by the whole thing again. Is there any change in the output? The way I typed it here and the way I would type it this way, would there be any change in the output? No. I said this thing pwd. See here, when I navigated using this method, I was placed in home directory 1 dir1a. I navigated from my home directory using this method. Again I was placed in this way, in this particular directory. The only change is here I was slightly more explicit while mentioning that in my current directory there is a directory called as directory 1 and inside directory 1 there is a directory dir1a, take me there. Again I am going to my home directory, I type pwd. Another way to navigate would be to mention the complete path from the beginning of the file system. So I said under root there is home, and under home there is dict, and under dict there is directory 1, and under directory 1 there is directory 1a. Ultimately I am there. Clear? So how you navigate with a relative path or with an absolute path does not matter as long as the path can be translated to a valid location. The command would take you there. But consider the case, I am typing some hypothetical path. See here, I said take me to America in New York. It says, what is this? There is no directory named America here, and there is no subdirectory with the name New York in a non-existing directory America. So obviously, when the path do not translates accurately, the command would anyways error out by saying no such file or directory. So what is important for you to understand? Wherever you want to navigate, you must know where exactly you want to navigate. So I said this time take me to /home /dict /directory 2 directory 1a. It says no such directory. Slash is there, root is there, home is there, dict is there, directory 2 is also there, but within directory 2 there isn't any directory called as dir1a. Instead there is indeed a directory called as dir2a. If I would have corrected this something like this, if I check now, I am there. So for you it's important to type in the correct path where you want it to be. Coming back to home is as simple as by typing cd. Another way to indicate a home is to say the tilde character. The tilde character is a shortcut to indicate your home directory. That's what we discussed in yesterday's session. This will also take me to my home directory. So cd enter takes you to the home directory. Cd tilde followed by an enter also takes you to the home directory. I again go to where I was earlier. Present working directory shows me that I am in dir2a. If I want to go to my home directory, I would also type this. Tilde is to indicate home directory of the current user. Tilde followed by a username is to indicate home directory of that specific user. Now that specific user is Dick in my case. So I said, take me to the home directory of Dick. So I am in the home directory of Dick. But can I do it by saying cd take me to the home directory of user 1? See what it says? Permission denied. Now why is it showing me permission denied? Let's examine the ls-ld directory attribute of user 1. See what others can do. So it's a directory. Only owner has read, write and execute permissions. Group members does not have read, write and execute, and others do not also have read, write and execute. That is why it does not allows me to go to that particular directory. Clear? If I say take me to the home directory of root, see what it says? Permission denied. I am wondering as to why it's not allowing me to go. It's because of the permissions. See, what can owner do? Owner is root. RWX, read, write and execute. What could the members of that root group do? Read, no write but execute. And what could others do? Nothing. And who am I with respect to that directory? I am other. I am others. And others can't do anything with that particular directory. That's why it's not allowing me to navigate. That doesn't mean the command itself is wrong. Command is correct. Now I try to do the same thing as the boss. That is the root user. Now I said, take me here. Nobody can stop the boss to go from anywhere in the system. I said, take me to. I am in the home directory of myself because I simply said tilde. I said, take me to the home directory of user 1. See where I am. I said, take me to the home directory of Dick. See where I am. So root cannot be restricted. The root user. Root can freely move throughout the system. Permissions are meant for general public. So cd followed by the path to a directory. So if I say cd dir1, the path of dir1 is not mentioned, which automatically means the current working directory. It would have been as good as by saying cd./dir1. cd followed by enter takes you to the home directory. cd followed by a tilde takes you back to your own home directory. cd followed by tilde and followed by username takes you to the home directory of that particular user. You may or may not be able to navigate because of permissions. That doesn't mean the notation itself is wrong. As a root user can always refer to somebody else's home directory. If I create a directory structure something like this and I say cd great grandfather to grandfather to father to child 1 to grandchild 1 to great grandchild 1. If I don't mention where is my great grandfather, the default assumption is it's in my current working directory. So I said cd dot slash, which means in my current directory there is a folder called as great grandfather. Inside it there is a grandfather, inside it there's a father, inside it there's a child 1, inside that there's a grandchild 1, and inside that there is a great grandchild 1. So understand the way you mention the path. You could have also said cd /home /user 30 /great grandfather. Now this is where from I am starting? From the slash, which is the beginning of the file system. To understand it in a better way, understand this. Let's not worry about the mkdir command. So I have created the entire directory structure in one go. So I said step by step. go to great grandfather. I am in great grandfather. I said go to grandfather. I am in now great grandfather grandfather. I said go to father. It has taken me slash home slash dick slash great grandfather grandfather father. I said go to child 1 Biswa. So I am in the directory slash home slash dick slash great grandfather grandfather father child 1. If I navigate further, I am here. If I navigate further, I am here. The best way to return to my base by saying cd enter. Now how could I navigate it? I could have said in my current directory there is great grandfather, grandfather, father, child 1, grandchild 1, great grandchild 1. I am there. Coming back to my home directory. If I want to mention path starting from the beginning of the file system, I would have mentioned slash home slash dick slash great grandfather grandfather father child 1 great grandchild 1 great grandchild 1. I am there. So how you mention starting from the file system, that is root, or with respect to your current position, that is up to you. That is what is our immediate next discussion, that is understanding the differences in an absolute path name and relative path names. So it's very important understanding for those who are new to Unix to understand how you mention the paths. cd slash home slash dick great grandfather grandfather whatever. In this case the path is mentioned starting from a slash, which is nothing but the beginning of my file system. cd minus a hyphen allows you to toggle between two directories. Toggling is between hopping. Previous directory, new directory. Previous directory, new directory. So on and so forth. See here. Understand where I am. This is my current working directory. I am going elsewhere. Say somewhere under TMP. So see where I am. So TMP is my present working directory. This was my previous present working directory or old present working directory. Now if I want to hop between two of them alternately, I can do by saying cd hyphen. I said cd hyphen, see where I am now. I said cd hyphen, see where I am now. I said cd hyphen, see where I am now. I said cd hyphen, see where I am now. So go to the directory where you want it to be. Go to the new directory where you want it to be. Then just keep on shuffling between them by saying cd hyphen. Once you type cd hyphen, you will go to your old PWD. You say cd hyphen now, again it will come back to the original directory. So you can keep on toggling between two directories by typing cd hyphen. Allows you to toggle between two directories, the current working directory and the previous working directory. I wonder how is this possible. One more time. Let's understand. How does Unix knows that where you were and what is your current position and how does it allows you to hop between them? So this is my present working directory. It can be also obtained by typing pwd command. So I said echo $pwd. So Unix somewhere in a variable keeps track of my present working directory. I go to the new directory now, somewhere under TMP. I said pwd, this is my new directory. I said echo $pwd. So present working directory is automatically stored as a value of a variable pwd. So it stores it in some variable. The name of that variable is capital case pwd. Command to obtain it is lowercase pwd. The variable where it stores that value of my present working directory is capital case pwd. Now understand this. Old pwd. See what it stores in old pwd? My previous directory. It stores it in a variable. And that's how when I type cd hyphen, it knows go to the old PWD. And now if I type what is my old PWD, it would be /tmp. Now if I say this thing, it takes me to old PWD. It says this thing, again back to my old PWD. So it keeps on changing the value of the variables, capital case PWD and old PWD. So I should write it here. How is this made possible? Linux stores the value of your present working directory in the variable PWD. It also stores the value of your previous working directory in the variable old PWD. Clear? This is how it helps you to toggle between current directory and the previous directory. To obtain the value of those, you would have said echo $PWD and $old PWD. It would print you the value of present working directory as well as your old present working directory. I told you cd tilde takes you to your home directory. Now for all of us, there is a small exercise, and that is to create a directory tree structure of this form. So each one of you today is supposed to create in your home directory a directory structure similar to this: movies, subjects, and sports. Within movies, you are supposed to create subdirectories such as action, drama, thriller, and FAV for favorite. So that is about your favorite generation of movies. In subjects, you should write language, or rather English, maths, science, and favorite. And in sports, you should create indoor, outdoor, and favorite. So this is the directory structure that you should create going forward in the lab, and then try to navigate from one directory to another this way, so that your understanding of absolute and relative path becomes clear. So I'm going to create these directory structures all in one go. So I would say, am I in my home directory? Then I'm going to create movies, action, or let me create movies and then go to movies and then create action, drama, thriller, and favorite. All of them are created. I am going one level up. I am back into my home directory. I am creating this time subjects. Then I am going to subjects and creating these many. I am under subjects and I can see English, favorite, maths, and science. I am creating one more, that is sports. Then I am going to sports and I am going to create indoor, outdoor, and favorite. I am back to my home directory. So I have now movies, subjects, and sports. Now understand this. I navigate to subjects, favorite. Did I mention any path for subjects? So what is assumed? Current working directory. So in my current working directory, there is a folder named subjects, and under subject there is a folder called as favorite. Take me there. So here I am. Now I want to go to sports favorite. So how would I navigate? /home /dig /sports /favorite. Right? So what is my PWD? /home /dig /sports /favorite. What is my old PWD? /home /dig /subjects /favorite. I can toggle between them. So between sports and subjects I am toggling. So understand this now. What is my current working directory? Present working directory? Home, dig, subjects, favorite. If I want to navigate to movies favorite, what would have been the path? This way, isn't it? It would have been go to /home /dig /movies /favorite. When you compare the path of your present working directory and the path of the targeted working directory where you want to jump to, what is the difference? Instead of subjects, you have to substitute with movies. So see what I say. I say CD. Understand first where I am. I said CD subjects with movies. This notation tells Unix that in my current path, wherever you see subjects, replace it with movies. So what would be my path then? My current path is this. If I replace subject with movies, what it would become? /home /dig /movies /favorite. Isn't it the same path where you want to go? So it is simply like search and replace. Whatever is the replaced path becomes then take me there, but this convention only works with corn shell. See what it says? What it says? Bash does not understand the way you have typed the command. Now I am using KSH. I typed, what is my PWD? I am still there. Home, dig, subjects, favorite. I type this notation now. This time there was no problem. I type what is my PWD. So corn shell can understand search and substitute, which bash shell does not. These are some of the minor differences amongst various shells. If I wanted to go to sports favorite, I would have typed. So in my current path, wherever I see movies, replace that movies with the word sports. Whatever becomes the target path, take me there. If I type my PWD, this is where I am. Clear? So this notation of search and replace with the CD command works only with the corn shell. Well, I am exiting back to my bash shell. CD movies subjects replaces movies from the current path with subjects, and then it takes you there, provided the path must be a valid path. अगर इस टाइप का कोई पाथ ही नहीं है तो obviously the command will error out saying no such file or directory. So to practice further, you must create this directory structure and then use various absolute and relative conventions to move across from one directory to another. We'll come back to that particular topic again in tomorrow's session, trying to understand absolute and relative path names. It will be an interesting discussion. If you want to, for your practice purpose, create an empty file, you can make use of touch command. So see it here. I'm back to my home directory. I wanted to create a file called as pune.txt. First, before I type it, is there any file called as pune.txt? No. Now I am saying touch pune.txt. It has created pune.txt as a file, as a regular file of the size 0 bytes. That's what I said here. Creates an empty file. Touch followed by file names will create file1.txt, file2.txt. Both would be 0 byte empty files. If file1.txt and file2.txt does not exist, it will create them as 0 byte file. Did I mention any path for file1.txt? That means it will be created under current working directory. Did I mention any path for file2.txt? If I didn't mention any path, it will be created under current directory. If any of the files mentioned above exists, then it will simply modify the last modification timestamp of that file. Understand, when was file 2 created? At 8:45. I am just filtering the output for file 2. So when was the file created? At 8:45. What is the current date and time? It's 9:38 a.m. today. If I say touch and I mention some file which already exists, see what happens. It simply changes the timestamp to the current timestamp. So understand the way touch command works. When you say touch followed by a file name, if the file already exists, it will simply modify the last modification timestamp of that file. It will not change the contents of that file. But if the file does not exist in the given path, then in that case it will create a 0 byte file with the current last modification timestamp as a 0 byte file in that whatever path you have mentioned. So touch command, it's important sometimes to have this command handy, at least during the initial sessions where I don't know how to create a file. In that case, you can create 0 byte files by typing touch command. So you see pune.txt was created at 9:37, and when I touched file 2.txt, it was 9:39 a.m. today morning. That's when my file got created, or file got touched rather. So this brings us to the end of the discussion in day 2. Tomorrow we'll learn few more commands. Until then, you keep on observing, practicing whatever we have been doing so far. The best way to master Unix command is to observe the way you type a command and the way it produces an output. Synthesizing it, it's very important. You see, simply keep on doing an exercise without due observations. That means there is no learning, there is no fun. I said just create the directory structure. You monotonously went on creating directory structure without observing, then it's of no use. So ideally, attend a class, understand what's being shown in the demo, the commands explanation. If things are not clear to you, go through the man pages, keep on typing those commands in the lab sessions, understand the way a command works, and that's when you can call it as a close of the day. Going back at home, it's enough of the computers in a given day. Going back at home, you must read out the text from Sumit Abadas's book, that is Unix Concepts and Application. That is one very user-friendly written style, and you can still go through it at home. So understand what he is trying to explain, understand the output, and once you are understood, then you can call it as a day, saying that's what I wanted to accomplish in a given day and I have already accomplished. But if you simply keep on just blindly following the commands, it's not going to help, because these commands with all the options will not be documented at runtime. You have to write your own options, and only those people who have understood those options and the way the option produces a command would be in a position to construct a command. So these are the initial days of your Unix learning. We are just on to day 2 after the theoretical discussion. So I am still giving you 8 more days to catch up. After 8 more days, we'll be directly on the fastest gear. We'll be writing shell scripts. Now, those people who have understood the commands well would only be in a position to write shell scripts. Because shell script is nothing but a collection of standalone Unix commands built together in a file with some logical flow to accomplish some routinely done activity is what we write in a case of a shell script. So that's it for this session. Thanks for joining in.